Hello, and welcome to an axe to grind, the manliest theft deterrent on the market. So let's start by going over my components. As you see here, I have a couple of deterrent devices. I have 2 speakers, my axe body spray, it's all lined up to spray out over here. It's tied to a string and a mechanism. This motor tightens and it pulls back on this part of the can, and that sprays it out. I have several vibration motors placed around the box. There's one more, let me see. Yeah, here. And I've connected them all to the little breadboard over here. So they're able to quite easily get like the power and stuff that they need together, and that's all connected to one pin. I also have MP3 players connected here as well. Right over here, you can see the photoresistor, which is and the LED as well. And the photoresistor is attached to this resistor over here, and all the components that need to get that going. There's a buzzer just to add a little extra chaos, as well as my IR sensor, and that LED, which I call a nightlight, and with photoresistors not being able to work in the dark, that was a cool addition to be able to just have that turn on and add an extra layer of making sure the package can't be stolen at night. So these are all of my components. So now that you've seen my components, we can check out the circuit diagram. You can see I have several components here, with my deterrent devices being the speakers, the vibration motors, the buzzer, and the motor which sprays the axe body spray. The IR sensor is what picks up, which is my arming device, and the photoresistor is the thing that detects whether or not the box has been picked up. So when we look at the system flow chart, there are 2 major states that my system is in. The first one is in the disarmed state, and the second one is the armed state. So while the system is in the disarmed state, it's continually checking to see if it has received a signal from the IR sensor. And when it is in the armed state, it has received that signal and it knows that it's armed, so it's repeatedly checking to see if the photoresistor is picking anything up, as well as if there's anything being picked up by the IR system to disarm the system. So while it is in the disarmed state, it is impossible to set off any of the deterrents because the variable arm object state is set at 0. So as a result, it is continually only checking the IR sensor, and the nightlight LED will either be enabled or disabled, and I've had it enabled at this point. I used the 4-digit IR passcode example code that was on campus under this assignment in order to help me arm and disarm the system. It works by having the user press the power button in order to enter the passcode, and the serial monitor displays the buttons that have been pressed. After that, the user is able to input the passcode, and if it is incorrect, it will merely tell the user that's incorrect, and the user has to go through the process of pressing the power button again in order to use it and try a different passcode. However, if the passcode is correct, it sets the variable, the arm object state, to 1 or 0. It enables it or disables it, which in turn will determine whether or not the deterrents are enabled. So while in the armed state, the deterrents are all idle and are able to be enabled if the danger variable is turned on, and that is happening because the photoresistor is constantly checking to see if it is seeing any light. So if the photoresistor sees any light, it will immediately enable the deterrents, which will all start spraying for a short period of time. The IR sensor is semi-idle. It's just not the only sensor that's going, and it's still possible to arm and disarm the thing at the state. For this project, I thought it'd be kind of fun and a little bit challenging to try to learn how to use functions in Arduino. So I did some research and was able to figure out how to use them. And I have two. The first one isn't really important, but it basically just checks if the arm state is set to 2, which would mean that it was originally set at 1 and then is now set to 0. And that one runs really quickly. But my larger one called moved detects whether or not the photoresistor is reading values. So as you see here in the if statement, it initially checks if the photoresistor is reading a value above 30. In that case, it can set the danger variable to 1, which would, once it is returned back to the code, would immediately start it from allowing the deterrents to fire. However, if it has been previously in reading above a value above 30, what will end up happening is that it'll run a second check and do a bit of a delay to ensure that it's actually reading a value that is below 30. And in that case, it can turn off the deterrents by setting a danger state of 0.